Hi all, so this is the foundation that we are going to design, and basically it is a 20 meter into 20 meter slab in which there are 12 columns present, and in these four types of columns are different, having different dimensions. Then the rest of all other columns are having the same dimensions. Like this column is of having 500 into 500 millimeter, and only these four, the middle four columns, are having another dimension, that is 600 into 600. Now we got these values from the analysis results of this building that we just did. So the from this we can deduce the results as this, that is for column 1 the dimension as well as the required and corresponding loads and the materials used. It can be obtained from the analysis results. So here it clearly states that for column number 6, 7 as well as 10, 11, the dimensions are different. The rest, the dimensions are all the same, but the dead load, live load varies. So materials used are M40 and HYSD 500, and it is constant throughout all the structures. So these are the materials and these are the loads, live loads and dead loads. So now next is the subgrade modulus, and it can be obtained from the formula, and the value is 3 into 10 raised to 4 kilonewton per meter cube. And next, this is the footing size, and all the dimensions are given. 2 meters is given allowance on either sides. So let's get back on how to design. Alright, so first what we have to do is to define the materials. So first we can go and define the materials, and you can see that there are two materials which I have defined, that is the HYSD 500 and M40, and we have to find the compressive strength and all those values. It can be easily obtained from internet or any other books or papers. So after giving all the values and defining it, next what we have to define is the slab properties. And slab property, as you can see, I have defined it with M40, and I have given the thickness and all. So after defining the slab properties, next what we have to do is to define the column properties. And there are two types of columns, two types of dimensions of columns, that is 500 to 500 and 600 to 600, and I have given the corresponding values. Okay, so after defining all this, next what we have to define is the soil upgrade properties, and we have to make sure that the value is 3 into 10 raised to 4, which we have just deduced from the equation. Alright, so after defining the soil subgrade modulus, next what we have to do is load patterns, load cases, and load combinations. So load patterns, we have to make sure that dead and live are there, and after that load cases, it's linear static, we are considering only linear. And after that load combinations, we have to make two combinations. First is one is for the ultimate load, and second is for the service load. And for the ultimate, the scale factor is 1.5 for both dead and live, and for combination 2, it is for service load, and the scale factor is 1, and the design selection is given as normal, long term, and initial for service. So after defining all this, next what we have to do is to draw this. So we can draw it from here. We can draw slabs, we can draw columns and all. So after drawing it, then next what we have to do is to draw the design strip, which you can see these are one design strip. Like these are design strips in the y direction, and there are design strips in the x direction also. So next we have to define draw the design strips, and after drawing the design strips, what we have to do is assign next after drawing a design, we have to assign the loads, and it can be done from going here assign. There will be support data as well as load data, so the dead loads and the live loads respective to their columns can be assigned from here. The dead loads and live loads are given, as well as the soil subgrade properties are also given. So after that we can run analysis. Okay, so we can run analysis from here. Go to run, and we can click. Oh, but before doing the analysis, we have to make sure that the rebar material is given by selecting like a strip or the footing and giving it as a rebar material, choosing HYSD 500. Like I chose this for the footing. Now wait a sec. This is for the strip and we have to give it as HYSD 500 for all the strips in both layer A and B. So after doing all that, okay, so after all doing all that, we have to run the analysis and we can go and run analysis. It takes a little time, and so the displacements are given and it varies, and it is given in different colors for the corresponding displacements, and the values are given in the right side. So after this you can go and click run analysis and design, and it is also complete, and you can see the punching shear design. So initially when I gave the thickness as less, I got the punching shear ratio as more than 1, like I got first time 3. So I gradually increased the thickness, and when it came to 1200 millimeter, this is the result that I got. Now it's satisfiable, and because the ratio is less than 1, so it is okay. Okay, so now you can see the values, like if we put show strip forces right for layer A and apply, you will get the strip forces in layer A, and you can choose layer B also, both layers. And if we need shear force, we can put it like that, and all are given. So after that you can also check the slab design, like put impose minimum reinforcement and apply, and you can get the minimum reinforcing values. And for layer B also, if you need, you can get in both the direction also, like in a layer A and layer B. So after that you can also see the crack widths. Also this is in the slab bottom face, and these are all minor cracks, so it can be negligible. So these are the top face. Okay, so after that we can go and run detailing. We have to click 3 options. Okay, all right, so go to drawing sheets, drawing component values, slab views. So this is the framing plan, and you can get the rebar table. So this is the rebar table. I mean, you will get the mark and diameters and the lengths corresponding, and you'll get the build quantities, the lengths used for the respective bar sizes, and the weight of the corresponding, and you'll get it is, you can get the value of reinforcement profile of layer A. Okay, top rebar plan, rebar plan of all the bars, bottom rebar plan. Everything can be get from the detailing. So thank you guys. So this is how we've designed it. Thank you.